Notes 1.1 is where we're going to expand tables, write the recursive equation, and then do some graphing. The graphing I'm not going to do a whole heck of a lot on because we guys did really good on this before. So this time we have a table. We start with -1 as our start time, and our start number is -2. When we expand the table, what's going to happen is first you write that first -2 because that's all we had. That's what we started with. Then to get to this -5 here, we do -2 minus 3. To get to this -8 here, we started with -2, we minused 3, and then we minused 3 again. To get to this -11, that's right here, again, we started with the -2 at the top, and then we minused 3 times. Okay, so -3 is our common difference. So when we write a recursive equation, it always is going to have f of n equals f of n minus 1. This is just formatting. Then we write our common difference or our common ratio, which in this case we were subtracting 3. Now this f of n equals f of n minus 1 just means to find our next number, we use the current number we have and then use the common difference or common ratio. So we started with -2, that was our current number. To get to that next number, -5, we minused 3. To get to the next number, -8, we started with our current number, -5, minus 3, and that's how we got that -8, and so on and so forth. We have to give our starting values, okay? So we write that as f of our start time, or our first x, which was -1, close that parentheses, equals our start number. Okay, this is how it's always gonna lay out. It's always gonna have this stuff in orange, and then it's always gonna have our starting values. And then I graphed the equation. So we had -1, -2, then we had 0, -5, and then we had 1, -8, and then I couldn't graph to -11. My graph didn't go any further, so I don't have to plot those dots. All right, so now let's do an example. So in this one, the table's already pre-filled out for you. At the beginning means time 0. We started with 3 dots. At 1 minute, we had 6 dots. At 2 minutes, we had 12 dots. So what do you guys think is gonna happen at 3 minutes? We're gonna have 24 dots. So the math that we're doing is we are multiplying by 2. So first we start with a 3. Then we did 3 times 2. And then to get to 12, we did, and then 3 times 2 times 2. So that's how we get to this 12. So again, it's always how you did you start with that first number to get to where you're at. That's what the expanded table is doing. So in this one, we started with 3, but this time we're gonna multiply by 2 3 times, okay? So when I write my recursive, this time I had x's, so I'm gonna use f of x equals f of x minus 1, and then our common ratio was multiplying by 2. We started with, so we gotta give our start values. Our start time was 0, so we have f of 0, and then our start number was 3, so it equals 3. And then I'm gonna go ahead and graph this. So we have 0, 3, 1, 6, 2, 12, and that's all I can graph. But see how it's curving? What type of sequence is this? Let's look at the next one here. So we are starting with a list. List always starts with time 1. So this 26 is our first number. So I'm gonna start with 26, okay? My second number was 20. Then we have our third number, 14, and our fourth number is 8. All right. So in my expanded, I start with my 26, and then I do 26 minus 6. And then to get to 14, I did 26 minus 6 2 times. And then we do 26 to get to 8. We minus that 6 3 times. So when I look at my recursive, again, it's always gonna start with this formatting. This time we're using n's. If you ever flip-flop between an n and an x by mistake, okay, but as long as your formatting is good, I'm good. So I'm gonna subtract that 6 because that was my common difference. I started with time 1, so I have f of 1 equals, and then my start number, 26. So it's a word problem. Go ahead and read that word problem. All right, so our start time is 0 because it says at the beginning. Miss Rawolf originally has 240 stickers, and then it says that she loses half. If you lose half, That is a geometric thing, so that means we're really multiplying by 1/2, okay? So when I start filling out my table, I have 1, 2, 3 on this side. Half of 24 is 120, half of 120 is 60, half of 60 is 30, which means when I start filling this out, I have my 240 originally. To get to 120, I did 240 times 1/2. To get to 60, I did 240 times 1/2 2 times. To get to 30, I did originally 240 times 1/2 3 times. So when I fill out my recursive, again, always starting with the formatting, f of n equals f of n minus 1. Our common ratio in this time was a times 1/2, so we write times 1/2. Then to write our start values, we started with times 0, and our starting number was 240. So I'm gonna go ahead and graph this. You guys can graph this on your own. So again, look at how my graph, it's starting to curve. So make sure your graph looks like mine. Again, you guys should be good with the graphing. The last one, we are given a graph, so that's nice. But remember, we always read graphs from left to right. All right, so I'm gonna start filling out my table. So I'm gonna look at my left dot. This is my most left dot. So I'm looking at that x value here, which is 1. And then that y value, or f of x value, is 16. Y and f of x are very interchangeable. My second dot starts at 2 and has a y value of 8. My next dot is at 3 with a y value of 4. And then my last one I can do is 4 with a y value of 2. Okay, so when I start writing this out, when I expand this, I always start with that 16. But how do I get from 16 to 8? That's the same as 8 to 4. That's the same as 4 to 2. I multiply by 1/2. That seems to be my favorite number today, is 2. So to get to 4, I did 16 times 1/2 2 times. And then to get to 2, I did 16 times 1/2 3 times. So when I start writing out my recursive, again, I have x's this time, so I'm going to use x's. But again, if you flip-flop them, not a big deal. F of x equals f of x minus 1. And then we have times 1/2. Then I write out my start values. So I have f of 1 for my start time, or my x value, equals 16, which was my first f of x, or my start number. All right, so the last little bit, I just want you to copy this out just so you know how to always write a recursive. This is no matter what. If you understand what's happening, go ahead and get started on your exit ticket and then your homework. If you need a little bit more, I got a couple more examples for you.